Remote sensing is observing a medium, a process, some phenomenon without ever coming in direct contact with that phenomenon. So unlike a lab experiment or where you go to a place and make an in situ measurement where you're actually touching the medium, remote sensing is observing it remotely from a distance. And this actually provides a different kind of perspective on things. When you're part of your medium, you're part of your experiment, you're part of the experience, you get one perspective that's crucial. You get a very different one when you're removed from it, when you're looking from space, when you're looking from 400 or 500 miles away, or in some cases 20,000 miles away. We can start up close, we can stand in a place and look at it, and we can zoom out, and all of a sudden it takes on new meaning. The trees are part of a broader system that sit on a landmass that is a country, that's part of a continent, that sits in an ocean. And as we step back further and further and look at those same trees, we may not see the leaves from far away, but we see the trees and how they fit into a broader Earth system, the clouds that surround them, the ice that's far north or far south of them, the oceans that really are affecting the climate that is causing those trees to grow.
Satellites are really the best way to measure the effects of climate change, because just one person on the ground in one place, it's very difficult to say if what you see in front of you is due to climate change or due to some local phenomena or is just the weather. And from space we can look at the whole Earth and we can integrate these observations of the whole Earth and really make a better assessment about what's causing these changes and what their long-term prognosis is.
A decade ago, the Earth observing system was beginning to be put in place. A series of satellites designed to observe the Earth, take a snapshot of the Earth over a period of years to understand its behavior. Well, to date, there are 14 Earth observing satellites orbiting right now. And of those 14, 13 are past their design life. They're living on borrowed time and could go away at any moment.
I think funding for these satellite missions is very much threatened right now. There doesn't seem to be a lot of support in political circles right now for these missions, and so that's something that as scientists we're trying to do, is to educate people about why these are so important. Like I said, the GRACE mission has been really, in my opinion, one of the best tools we have for measuring the impacts of climate change on the Earth. It tells us where the water is going, and that's, when we talk about climate change, everybody thinks about the temperature, but it's really the water availability that's going to be the big impactor. And so we'll be able to tell with GRACE, where we're losing water, where there's going to be prolonged droughts, where there's going to be more flooding, where the ice is melting. It's just this wonderful tool, and now we're going to lose this tool for probably 2 to 3 years. And it's really unfortunate that we've kind of taken away one of our eyes in the sky.
The Earth is changing in ways that will affect our lives. And just as we're realizing how and why these changes are occurring, our ability to understand them is diminishing. And frankly, our future, our success in the future as a society really is intimately linked to our ability to anticipate what's coming.